Okay, today's video is on lesson 5.1, perpendiculars and bisectors. So in this chapter, we're going to be developing some ideas further on triangles, and we're going to start off with these perpendiculars and bisectors. So first of all, perpendicular bisector is a segment, a ray, a line, or a plane that is perpendicular to a segment at its midpoint. So basically, you can only have a bisector of something that ends. So that could only be a segment. A line goes on in two directions forever. A plane extends in all directions forever. So you could never find a bisector of that. But a line segment you can find the bisector of because it has endpoints there and there. So if we're looking for a perpendicular bisector, we're looking for something, and it's either that something is either a segment, a ray, a line, or a plane that bisects a line segment, so it cuts it into two equal parts, and it is perpendicular to that segment. Okay? Now, we're going to develop that idea into this perpendicular bisector theorem that says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what that means is, here's our perpendicular bisector. It cuts this line segment exactly in half, and it's 90 degrees. Any point that is on this perpendicular bisector right here is the same distance from this endpoint as it is from this endpoint. So if I were to draw a line or a point right here, the distance from that point to that end point is the same as the distance from this same point to that end point. Now if you use your imagination and draw those segments in, you notice you have two triangles that are formed. More triangles, just what you wanted. All right, then the converse of that perpendicular bisector theorem says that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So if we don't know that this is the perpendicular bisector, but we know that a point that's, say, right here is the same distance, we're given that it's the same distance, then we can say, okay, this point has to be on the perpendicular bisector. So we're looking at the converse of that theorem. All right, so here's some examples. Example number 1, why is FA equal to FB? Well, we know that this is the perpendicular bisector. How do we know that? Because it's perpendicular, which is what that symbol there indicates, and we know that we have two congruent segments. So because point F is on the perpendicular bisector of AB, that means that FB and FA are the same length. Okay, so hopefully that makes sense. The next one is the angle bisector theorem. So we're talking about line segments and bisectors of those line segments. Now we're looking at angle bisectors. So this angle bisector theorem says that if a point is on the bisector of an angle, so now we're cutting an angle into two congruent parts, it is equidistant from the two sides of the angle, and it has to be perpendicular at those two sides. We'll look at an example of that in just a second. The converse of that is also true. So if we have a point that's on the interior of an angle and is equidistant from the sides of the angle, then it has to be on the bisector of that angle. And remember, they have to be perpendicular to the sides of the angle. So let's look at what that means here. So here's an example. And we have this drawing on the left, and it says that I is the bisector of angle GTF. Okay, so I bisects it. So what we've known so far is that this angle here is congruent to this angle here. That's all we've learned so far about bisectors. But now we're adding to that, and we're saying that, okay, IG is perpendicular, which it has to be, and IF is also perpendicular, which it has to be in order to use that last theorem. They have to be perpendicular, because otherwise we could say, well, IF is down here, And that's clearly not the same distance as IG. So we have to note that they are perpendicular to each other. Okay, so then if I is the bisector of that angle and IG is perpendicular to TG and IF is perpendicular to TF, then we have to prove that IG is perpendicular, or is congruent, excuse me, to IF. And that's using that angle bisector theorem, because the point is on the inside of the angle and it is perpendicular and equidistant from the sides, so therefore it's on the perpendicular bisector. So that's that converse of the angle bisector theorem. All right, so what does this have to do with anything, and when am I ever going to really have to think about this? Well, here's a real life example for you. It says, suppose that in constructing a wooden roof truss, okay, those are the pieces that are in your attic that hold up the roof, BC and BD are installed so that angle ACB and ADB are right angles, and that AC equals AD. Okay, so we have that congruent there. What can you say about angle CBA and angle ABD? What can you say about those two angles? Try that one out and bring it to class tomorrow. We'll discuss this further together. If you have any questions, make sure you write them down, and have a good night.